Hey guys, this is Rachel Gregory again. I'm in SES 141 and I attend Arizona State University, and today we're going to be doing another science experiment involving solar water desalination. So, I have all my materials here. I have my salt, which I'll be pulling out of this little container. I have my half a teaspoon, my bigger glass container, my smaller glass container, my spoon for mixing, some rocks, my exact cup of water, and my plastic wrap. I'm going to begin the experiment by pouring my cup of water into my large glass dish. I'm now going to take my salt and my half a teaspoon, and I'm going to add the half a teaspoon of salt to the water I just poured into my dish. I'm now going to mix the salt in with my spoon. I'm now going to take my small dish and place it in the water in the middle of the large glass dish. Bear with me now, but you're going to have to patiently watch me cover this with saran wrap. Now that my covering is done, I'm going to take the rocks and place them right in the middle of my plastic wrap. They're going to act as a weight on the plastic wrap. Now here's the finished product. I'm now going to take this outside, let it sit for 2 hours in the sun, and I'll let you guys know how it goes. Alright, hey guys, so now it's time to go over my results and answer some questions that were part of the assignment. So let me open this here. I'm taking the rocks off right now. Sat outside for about 2 hours and 35 minutes. We have a little bit of moisture on here. Alright, so we did okay. There's like a few sips in here. I don't know if you can see that. Maybe if I tilt the water around. There's not much, but there's some.
As for the taste, it's not salty. It tastes like normal distilled water that you buy at your grocery store.
As for the salt water, that definitely still tastes very salty. So to start with the questions, question 1, how much desalinated water did I get? I got a few sips worth, probably actually 1 big gulp, maybe 2 small sips. So not much. Question 2, I believe the solar was pretty effective in distilling the salt water. Without the heat, it probably wouldn't have done nearly as well. And the sun is one of the main drivers that push evaporation, and because the plastic wrap was on top of the container, none of that evaporation was able to leave, making it lead right to the middle where the rocks were, dripping right into my container to create this experiment. Question 3, as you guys saw before, I already tasted the water, but I'll taste it again. The container in the middle with the desalinated water tastes like your normal distilled water that you get at the grocery store in the drink aisle, and the salt water definitely still tastes very salty, and the normal tap water definitely tastes different than the distilled water, because in normal tap water there's minerals, there's a little bit of sodium, and when water evaporates up into the plastic wrap, it only takes the water. It does not take the minerals with it. So once it drips down into the glass, all that's falling in there is plain distilled water with no added minerals that are in tap water. Question 4. So the thermal radiation from the sun beats down as visible light onto the glass as well as the concrete underneath the glass, and then conduction occurs to the glass because when you have one surface come in contact with another surface that's of a different temperature, conduction starts occurring. So the glass starts to heat up once it's in contact with the concrete and getting pressure from the visible light. Then we get convection currents. Once the glass starts heating up the water will start circulating. So basically, the cold water will sink, the hot water will rise, which is caused by the transfer of heat through molecular motion in the water. So because this convection is occurring, the water is heating to a point where it's going to change state into a gas. And once that water turns into a gas, that gas is now evaporation. And because there was this plastic wrap on top of the glass, there's nowhere for this water to evaporate to, which is why we get the water droplets falling right into this middle glass right here. Question 5. So the size and shape of the outer container definitely affects its efficiency. So if there's more surface area, then there's more area for water to evaporate up onto the plastic wrap, and then there's more availability of water to make it to the middle container, which leads me into question 6, where let's say you had the same size container, but there was just more water in it. It honestly wouldn't change the efficiency of it because of the fact that you're still evaporating the same amount of water in the same amount of time. There's just more water in your bucket. But if you spread that water out over a larger surface area, then there's more water to be evaporated at a given time. Question 7. So one suggestion that I might have is trying the experiment again with a larger glass container with more surface area and see how much of a difference it actually makes having more surface area for water to be evaporated out of. So that is a possible scenario for next time. Thank you for watching, and I hope you enjoyed this video.